Hi everyone, welcome to today's Leetcode challenge. So today's problem is linked list cycle. So we're given the head of a linked list and we have to determine if the linked list is a cycle. So basically what we're given is in this, we're given a linked list and we have to just determine if it's actually a cycle, which means the end of the linked list or the tail of the linked list is actually connected to another one of its nodes. So as always, before getting started, I'd like to first identify what the inputs are and the outputs are. So let's get started. So initially, let's identify what the input is. So the input of this problem, let's take this first example. We're given the head of a linked list, and then the position is also given as an input, which is 1. So basically, the head is we're actually having a cycle at the position 1. Then let's also identify what the output is. So the output in this case is true. So this is an example. And before getting started, let's also identify what the constraints are to this problem. So we're given the constraints as follows. The number of nodes in this list is from 0 to 10 to the 4, and the node value is from negative 10 to the 5 to 10 to the 5, and the position is -1 or a valid index in the linked list. So these are our constraints. So before getting started, let's talk through the logic for this problem. So let's explain the logic. So let's take the first example that was provided, which is 3, 2, 0, -4. So let's assume that this is our linked list. And we have our head starting at this position and our tail at this position. So we are told that at position 1, which is at this position, it is actually being a cycle. So basically what it means is, let's put a C over here to indicate that this is where it's being connected as a cycle from the end of the linked list. So basically there's going to be a pointer that's coming from -4 going all the way to 2. So it's going to be in cycle. So now let's understand how to determine this cycle. So basically what we do here is we're going to take like a 2-pointer approach where we have a slow pointer and then we also have a fast pointer. So what happens is the fast pointer moves twice as fast as the slow pointer. And when it actually does that, what happens is while it's moving twice as fast as the slow pointer, in one cycle, if the fast pointer and the slow pointer converge, then that is an indication that it is a cycle. So basically, if the slow pointer moves once, the fast pointer moves twice. If the slow pointer moves once, the fast pointer moves twice. So after this, it's going to, the next position after -4 is going to be, fast pointer is going to come back to the 2 position. And then the slow pointer moves once, and then the fast pointer moves twice. So at this point, the slow and the fast converge. So basically, this indicates that we have a cycle. That is how we determine if the linked list has a cycle. So I hope that explains. And let me explain how the logic for this works. So first step is to check if the head is null. If it is null, then you return false. Otherwise, you set the slow pointer initially as head, and then you set the fast pointer also as head. Then you have a control loop. You have a control loop that moves slow and fast pointer. Then if the slow is equal to the fast, then you return true. Otherwise, if it does not do that outside the control loop, you return false. Now let's code this out. Okay. So initially we're checking if head is none. If it is none, then we just return. Then the next step is to set the slow pointer to head and the fast pointer also to head. And then after that, we use a while loop to say if the fast pointer is not null and fast.next is not null, as long as they are valid. What we do is we move the slow pointer by 1, so slow is equal to slow.next, and the fast pointer by 2 steps, so fast is equals to fast.next. And then while doing this operation where you move the slow pointer by 1 step and then the fast pointer by 2 steps, at any point if the slow pointer is equal to the fast pointer, then we know there is a cycle. So we just return true. Otherwise, outside, like going through this entire loop, if it doesn't return true, then outside we would just return false. Yeah, so that is it. Let's try to run this and see if this works. What do you know? It works. So let's try to submit this and see. Great. So it's as you can see, it works. It's pretty time efficient and memory efficient as well. Thank you so much for watching, and hope you have a great rest of your day.